Hello everyone, this is Dan Sandler again, coming to you with part 9 of our 10-part series where we set up Hadoop in the Amazon cloud and stream Twitter social media data to that environment. So at this point in time we have everything set up, everything configured from Flume streaming Twitter data to our Hadoop file system. We have Hive set up and configured. We have the Uzi workflow running without the ready indicator so that there's no wait event. So right now we're going to focus on this portion, which is basically to set up some ODBC connections to the environment and just run some basic queries. So there's some additional steps involved to get this configured. It wasn't as straightforward as you would imagine. So the first thing we have to do, okay, is we have to install Hive server. So Hive server is there's two Hive servers. There's Hive server 2, which is new within other distribution Hadoop release 4. And Hive server is the old one. They keep both around. Hive server allows us to get access to the ODBC environment. If you just went with Hive server 2, which is what we have in our environment, we wouldn't be able to access it. Cloudera has released a new, I guess it's a new package within their distribution of Hadoop called Impala. As of now, it's still in the beta release. That would allow us to get ODBC access without having to set up this Hive server. After many hours, many attempts to get Impala and ODBC connections working, it didn't work. So for now, the workaround is simply to set up the Hive server, get that running, and then we can get ODBC access to the environment. Okay. So I've already installed Hive server, so it's going to say it's already there. Everything's there. So all you have to do is say yum install Hive server, and that will bring down the libraries needed to run the Hive server. After you do that, you need to open up a few additional ports for the firewall. So the first thing is configure these ports. Okay, so the new ones are 10,000, 9083, and 10,001. 10,001 is in 9083. Those are the ones that we would need open. I've opened up 10,000 just in case we have Hive server access to the Hive server 2, because that's what Hive server 2 runs on. And that's the default port to connect into Hive. 9083 is the Metastore port, so to get metadata, it's going to listen in on that port. And then finally, 10,001 is where we're going to configure this new Hive server that we've just installed. We're going to configure that to run on this port. Okay, so you set those ports up, of course, by saying add, specify the port, blah, blah. So I'm just going to cancel that because I've already added them. But you can add them just by following those steps. Then you can close. Okay. Now, this opens it up on the host side, but on the, of course, we have our security group within the EC2 instance. So for here, you have to open up the ports explicitly as well. So as you can see here, you can just add custom rule and then 10,001, say add rule, then apply rules. Okay, that'll register those ports on our security group. So I've already got those set up. And these are steps you've already been through, so I imagine you're already caught up to speed on how to do that. But here are the ports that we have opened up here, just so you have those for reference. Okay. So now that we have the port set up, we've installed the Hive server, we need to edit the Hive server configuration. So when that service runs, we're going to edit /etc default Hive server. Okay. Right now you probably see just this commented out port. You're going to specify port equals 10,001. Of course, that's what we want this port to run on. By default, it will listen, or it will run on port 10,000, but there will be a conflict between Hive Server 1, this one, and Hive Server 2, the one we need running for Cloudera distribution of Hadoop 4. Okay? And this is a workaround, hopefully a temporary fix until we figure out how Impala to configure that for ODBC access. And when that day comes, I'll post another video on how to do that. Okay, so with that said, just have to, I'll stop my server and then I'll restart it. So sudo service Hive server stop. I'll stop it. So that's stopped. And so what you're going to say is start. So that'll start it up. I will check the logs. Var log Hive. You'll see now three log files. So I'll look in here. So this has been deprecated. Blah, blah, blah. Don't worry about that. It means it's running. So what we now have is the Hive server, the version of the Hive server we need to run to have ODBC access. And we have the ports open up, so what we can do now is download the Cloudera ODBC drive. Actually, it's not the. This is not the download we need. We need to get the download from mapr. Sorry, mapr ODBC. So the mapr ODBC driver, I reference it because you can download it, you can install it, and there's no sort of trial period. What they actually, you can see here, you can download 64-bit or 32-bit, depending on what you need. So you can go to this link and you can find the executables here to install. So once you install it, you of course will have the driver in your ODBC. So I will say okay. So you're going to see the driver actually show up when you install it as mapr Hive ODBC connector. They actually, so mapr is licensing Simba Technologies, their ODBC driver, and this is actually this ODBC driver is used with other vendors, including mapr. So it's a very frequently used. I've seen a couple of vendors, some of them niche, and I think Hortonworks might actually use them as well. But mapr was the only one that I could find where, through their distribution of this driver, you can download it and install it without restriction. So we are going to add a new user data source using the mapr Hive ODBC connector. We'll finish. Data source, we'll give it something as Cloudera AWS mapr. Okay. For testing. The host. I've aliased this in my host file, the IP address, so you can give it the IP address, you can give it the host name that you see for the instance in the cloud. So in this case it would be something like that or that. So whatever you want to give, that's fine. I like to have the alias. Makes it easy to remember. Cloudera dot AWS.com. Okay. The port, as you remember, we specified is 10,001, and we're going to say default. So at this point, there is no authentication. We're just going to test. In the database, it doesn't matter. Just leave it as default. So we've tested it. As you can see, it comes back, not a problem. We'll hit OK. So now we're ready to set up some connections. So I'm going to show you two ways to access the information. One of which will be I'm going to set up a pivot table custom source and then set up a query to aggregate some information. And as that runs, I'll then show you how to run it in a standard database client. So we'll go to pivot table window. By the way, one thing I should mention is I actually have the Microsoft ODBC driver, which has a plugin for an add-in for Excel. It's called the Hive pane. I've only gotten this to work with when I had Hive, Hadoop on Azure and the Amazon cloud and the Microsoft cloud, Azure running in the Azure cloud. I cannot get this to communicate with Cloudera distribution of Hadoop. I'm not surprised. I mean, obviously, Microsoft has an agreement with Hortonworks. They want to make sure that their connectivity works with their through their partnered distribution of Hadoop using Hortonworks in Azure. So, if you happen to figure out a way to get this, there's some sort of, I guess, WYSIWYG features here, but I'm mainly interested in just getting connectivity so I can run queries against a tweets table. I don't need to have all these features. I mean, frankly, if you can set this environment up and you need query access, you probably don't need this as well. So we'll say power pivot window. So I've already set this up before, so I'm just going to do another one. I'll say, so again, you go from this tab, power pivot, to power pivot window. You're going to say from other sources, okay? Get external data from other sources. You're going to say, scroll down here, and there's others, okay? So this is under relational databases, others. We're going to say custom, and we'll give it a friendly name. We'll say test Hive ODBC. We're going to build the connection string. We're going to use what we just created here, which is called Cloudera AWS mapr. That's what we just created. The username is the Hive username and password that we set up in, I believe it was exercise 6. Okay, and we want to save the password as well. And so the initial catalog to use, it doesn't matter. Just say test connection. So test connection has succeeded. That's a good sign. We will go to advanced now. Actually, no. We're just going to hit OK. So we have the connection that we need. Okay. We're going to hit next. We're going to say write a query that will specify the data to import. If you go the other route, what it's going to do is basically the driver is going to it's going to prefix all the tables with default. The tables live, the tweets table, for example, it lives in the Hive database. So because the driver prefixes everything with default, that's not going to work for us. So the way to get around that is you're going to say, you're just going to build a custom query. So for this one, we'll say tweets by time zone. And this is where you can see this is Hive query language that we're going to plug in here, but it's really about as SQL as you can get. So here's I'm going to reference Cloudera's. They have provided these queries as part of the tutorial, and it's very helpful. Of course, you can extend these as you need to, but it's a good starting point to see how, because the tweets table is, we can see here, if I describe the table, you'll see it's not your vanilla flat database table. It's kind of an object, which makes sense because it's an external table referencing a JSON object. So you can see here it's got a structure. It's got actually two structures. Entities, which covers, actually it's got embedded structures here, so hashtags, you can have multiple hashtags, those all get flattened out. You have user as its own structure where it kind of gives you more verbose information on the user itself, and then of course the tweet, the information about the tweet itself. So here this is going to get the count of tweets by time zone. So I'm just going to plug this in as is. Going to hit finish. Oops, I already have that name, so I'll say test. So this is going to actually run, and in doing so, it's basically running a Hive query. Of course, we know that any Hive query is going to produce a MapReduce job on the covers, at least one that involves aggregation, sorting, filtering. In this case, we are doing aggregation and filtering. Sorry, aggregation and sorting. So right now I don't see it running. It's instantiating, so I'll give it a second. In the meantime, I'll flip over to my database client. So we're going to do the same thing, except for those who don't want to live in Excel, and if you're just running queries ad hoc, it might be overkill to kind of flatten it out in Excel to begin with. You might want to do that once you have a sort of known canned query, but if you're just doing some ad hoc querying, you probably just want to jump into something like SQL DBX. So SQL DBX allows us to basically connect in using the native database connectivity, or in this case, we're just going to use ODBC. So I'm going to say new connection. I'm going to select the map.r DSN that we created. Of course, the same Hive. This is going to connect in. Let's see how this is going here. So you can see here the jobs are running. Okay, so that's the user time zone. The one thing I should make a note of, these queries run incredibly slow in the environment as I currently have it. This is not a performance exercise, so you'll probably be saying, why is it taking so long? It's just because it's running so many layers involved. It's ODBC, it's the client, it's Hive, it's MapReduce. So this is where, if you have this spread out on a bunch of nodes, this is going to run a lot faster. Right now, I basically got one node, 2 CPU box, so running in the Amazon cloud. So between the network and everything else, this is basically what you see. You get what you pay for, I should say. So one thing I'm going to show you is that the way this will display the catalog, basically the schema objects, for lack of a better term, it's going to show you not this sort of object view. So like we know user and entities, that's a structure. It's basically showing it as a string. So it's not really state-of-the-art in terms of the display. The tools haven't really caught up to the sort of elaborate structure beneath this. So you really have to understand this is a very flat view, but this is really the underlying view in order to effectively query this. So one thing I'm going to do is I'm going to take another query that Cloudera has provided as part of their tutorial, which is going to get the hashtag totals. Okay, and it's going to do a lateral view explode, which basically says take all of these hashtags, which are basically multi-valued set, and it's going to make those I'm not sure how it stores it, but it's basically multi-valued set. It's going to make those multiple values in a single rows into themselves, so you can get all the hashtag count for the tweets that we've captured. Okay, so I'm going to run this now. It's going to limit it by 15, so at the top 15 essentially. So this is running. And again, I'm going to go back to the job tracker, see how we're doing. So you can see this is still running. It's done 2 maps. One map is completed. It's doing the second one right now. It hasn't started the. It's done at 1 reduce. It looks like percentage complete is 0. So we can actually look at it here. So it has. It's still doing the second map right now. So let's see if the second. Yep, we got 2 things running right now. And this is very SQL-like. There are some nuances to, for example, I know SQL quite well, whether it's Oracle, DB2, doesn't matter. I've never seen a lateral view explode before. Okay, that's new to me. That has to be something that is very HQL, Hive query language specific. And you can see that you can alias things. Okay, so hashtags.text, actually that's not one, but you could alias like tweets as give it a table alias and then reference it in the SQL itself. But basically the nature of these structures within the table definition allows you to sort of treat these as objects essentially. The table is an object with sort of the varying the varying cardinality between the sets are basically what allows you to go back and forth. So this is still running. So it looks like it's kind of deceiving. You'll think because one disappeared, it's actually done, but it's actually spawned another process. We'll see it come up in a second. Because I go back to the oh, it's actually done. Yeah. So the import is in progress. So basically, the handoff is between now. It's gotten the result set. It's handing it back to Power Pivot, and the import is working. And so we should see what it looks like. It's basically going to give, well, slightly different counts because I ran this a few minutes ago, almost an hour ago actually. And I think at the end of the day, you know, I'm coming at it from a data person's point of view. It's you know, the effort is to get the data in, so you have basically the information you need. It's in a structure that makes sense, and once you understand what that structure looks like, you can run some queries against it. So everything else in between, making sure like the Uzi workflow is ignoring basically it doesn't have that weight condition, that the Hive site.xml is ignoring the temp files that are produced by Flume. You know, that was kind of one of the things, you know, I personally struggled with. But once you get that settled and you understand how to set up the configuration in other scenarios, then you can really focus on getting the data in and running some queries against it, which at the end of the day, that's what the business cares about. So this takes a while to import. Let's see how we're doing over here. So this one's still running. And you'll see that Cloudera has connectors for MicroStrategy, Netezza, Teradata, Tableau. I'm sure their support for other tools are growing. Essentially, if you have ODBC access, you can follow this exercise, follow these steps, and any ODBC compliant tool will be able to support it. And connect into it and then query it. I have not personally been able to get JDBC connections to work. That has been a struggle. My guess is that I'll have better luck if I go the Impala route, the Cloudera Impala. So we shall see if that works. I'm not. The reason why I have a desktop tool, which I'll show in the final part of our series, which will actually show this tool, which basically allows us to do some more analytic, some more natural language processing, the data science and data visualization portion of taking social media, parsing it out, and seeing what the sentiment is. That's kind of where that's a holy grail for the exercise, which will be the focus in the last part of our series. So completed, 15 rows transferred, so a lot of weight for what is a relatively small data set. So you can see you can get the breakdown by time zone, by day, the total count of tweets. So of course, not surprising where these time zones fall. What I've seen is that you could get more granular demographic information based on the user profile. Sometimes there is more location-specific information, but I think this is a pretty broad and vanilla breakdown for the first sort of, okay, here's one way to look at the data. Then you can drill up, roll it up, or slice it in other ways. So we've also just gotten these results back. So you can see here, you can begin to look at the hashtags within the universe of tweets that we've streamed to our environment. And I'll go back and I'll see, yep, all the jobs are completed. So this is essentially the final part of the instructional portion of the series. Just to recap. So right now we're at step 9. Basic Hive queries using ODBC. The next portion and the last entry to this series will be, I'll do a demo of 2 things. Streaming Facebook data to the environment, the basic approach I took, and how it's very different than the streaming Twitter data. Completely different mechanism, completely different Flume configuration. The one takeaway you'll probably have is how you configure 2 sources, 2 channels on the same Flume agent, because that will give you an indication of how you can multiplex the streaming data. The other thing I'll show you is I'll give you an indication of how you can begin to analyze the data. Now, once the data is in there, the whole measuring sentiment, natural language processing, machine learning, and overall data science that's probably a 20-part series, and I'll leave that to the experts. I'll just show you my little sandbox, my little sort of. I took a few tutorials. I basically combine them together so that at the end of the day I can, have a network diagram showing who the center of the universe is for a given topic within our tweets. Also, formulated tag cloud, and then finally how to do some clustering of the data by leaders, followers within this social media sort of microcosm. So this is it. This is the last instructional part. I'll have demo and parting thoughts in the next entries. I hope you're finding this useful. Hope you're finding this to be worth your while. And feedback, as always, is welcome. You can ping me at Data Dan Sandler. That's on Twitter at Data Dan Sandler. You can also follow me on my blog. I blog at least twice a week. I've got a lot of things queued up. Please follow me. Check me out, www.datadansandler.com. Till then, take care.